Hello everyone, this is Mr.S.M.Utage, working as Assistant Professor in Mechanical Engineering Department, Walchand Institute of Technology, Solapur. Today we will be discussing about errors in measurement. At the end of this session, students will be able to explain about different errors which we encounter during the measurement. The following contents will be discussed in this video lecture: error, types of errors in measurement. Error. It's the difference between the measured value and the true value of the measured dimension. So we can write the general formula for error in measurement as measured value minus true value. The error in measurement may be expressed as an absolute error or a relative error. Absolute error. It is the algebraic difference between the result of measurement and the conventional true value of the quantity being measured. Relative error. It is the quotient of the absolute error and the value of comparison used for calculation of that absolute error. This value of comparison may be the true value, the conventional true value for the arithmetic mean for series of measurement. The accuracy of measurement and hence the error depends on so many factors such as calibration standard, workpiece, instrument, person, environment. No matter how modern is the measuring instrument, how skillful is the operator, how accurate is the measurement process, there would always be some error. It is therefore attempted to minimize the error. So in order to minimize the error, usually a number of observations are made and their average is taken as the value of that measurement. These observations are made under identical conditions, that is same observer, same instrument and similar working conditions excepting for time, then it is called as single sample test. If however repeated measurements of a given property using alternate test conditions such as different observer and different instruments is made, the procedure is called as multi-sample test. The multi-sample test avoids many controllable errors, example personal error, instrument error, etc. The multi-sample test is costlier than the single sample test and hence the latter is in wide use. In practice, good number of observations are made under single sample test and statistical techniques are applied to get results which could be approximate to those obtainable from multi-sample test. Types of error. During measurement, several types of error may arise. They are static errors, which include reading errors, characteristic errors, environmental errors. Then there is instrument loading errors. Then there is dynamic errors. So this is the main classification. Static errors. Static errors result from the physical nature of the various components of the measuring system. There are three basic sources of static errors. First one, reading errors. Reading errors apply exclusively to the readout device. These do not have any direct relationship with other types of errors within the measuring system. Reading errors include parallax error, interpolation error. Attempts have been made to reduce or eliminate reading errors by relatively simple techniques, for example use of mirror behind the readout pointer or indicator virtually eliminates occurrence of parallax error. Then there is interpolation error. It is the reading error resulting from the inexact evaluation of the position of the index with regards to two adjacent graduation marks between which the index is located. How accurately can a scale be read? This depends on the thickness of the graduation marks, the spacing of the scale division, and the thickness of the pointer used to give the reading. Interpolation error can be tackled by increasing using magnifier over the scale in the vicinity of pointer or by using a digital readout system. Then comes the characteristic errors. It is defined as the deviation of the output of the measuring system from the theoretical predicted performance or from nominal performance specifications. Linearity errors, repeatability, hysteresis, and resolution errors are a part of characteristic errors if the theoretical output is a straight line. Loading errors. Loading errors result from the change in the measurand and itself when it is being measured. Instrument loading error is the difference between the value of the measurand before and the measuring system is connected for measurement. For example, a soft or delicate component is subjected to deformation during measurement due to the contact pressure of the instrument and causes a loading error. The effect of instrument loading errors are unavoidable. Therefore, measuring system or instrument should be selected such that this sensing element will minimize instrument loading error in a particular measurement involved. Environmental errors. These are the errors resulted from the effect of surrounding the temperature, pressure, humidity, etc. on measuring system. External influences like magnetic or electric fields, nuclear radiation, vibrations or shocks, etc. also leads to environmental errors. So this can be reduced by controlling the atmosphere according to the specific requirements. Dynamic errors. Dynamic errors is caused by time variations in the measurand. It results from the inability of the system to respond faithfully to a time varying measurement. It is caused by inertia, damping, friction or other physical constraints in the sensing or readout or display system. For statistical study and the study of accumulation of errors, these errors can be broadly classified into two categories. One is systematic or controllable errors. Second one, random errors. Systematic errors. Systematic errors are regularly repetitive in nature. They are of constant and similar form. They result from improper conditions or procedures that are consistent in action. Out of the systematic errors, all except the personal error varies from individual to individual depending on the personality of observer. Other systematic errors can be controlled in magnitude as well as in sense. If properly analyzed, they can be determined and reduced. These are also called as controllable errors. Systematic errors includes calibration errors. This occurs due to the variation in the calibrated scale from its normal value. The actual length of the standards such as slip gauge and engraved scales will vary from the nominal value by a small amount. This will cause an error in measurement of constant magnitude. Sometimes the instrument inertia and hysteresis effect do not allow the measurement to transit the measurement accurately. Drop in voltage along the wires of an electric meter may include an error in instrument. Ambient or atmospheric conditions. Variation in atmospheric conditions at the place of the measurement from that of internationally agreed standard values can give rise to error in the measured size of the component. Instruments are calibrated at the standard conditions, therefore error may creep into the given result if the atmospheric conditions are different at the place of the measurement. Out of this, temperature is the most significant factor which causes an error in the measurement due to expansion or contraction of component being measured or of the instrument used for measurement. Stylus pressure. Another common source of error is the pressure in with which the workplace is pressed while measuring. Though the pressure involved is generally small, but this is sufficient enough to cause appreciable deformation of both the stylus and the workpiece. In ideal case, the stylus should have simply touched the workpiece. Besides the deformation effect, the stylus pressure can bring deflection in the workpiece also. Variations in the force applied by the anvils of micrometer on the work to be measured results in the difference in its readings. In this case, error is caused by the distortion of both micrometer frame and workpiece. Avoidable errors. These errors may occur due to parallax, non-alignment of workpiece centers, improper location of measuring instruments, separating the thermometer in sunlight while measuring temperature, the error due to misalignment caused when the central line of workpiece is not normal to the central line of the measuring instrument. Random errors. Random errors are non-consistent. They occur randomly and are accidental in nature. It is difficult to eliminate such errors. Their specific cause, magnitude, and source cannot be determined from the knowledge of measuring instrument or the conditions of the measurement. The possible sources of such errors are small variations in the position of setting standard and workpiece, slight displacement of lever joints of measuring instruments, operator error in scale reading, fluctuations in the friction of measuring instruments, etc. Now pause this video for a few seconds and try to write answer to the following question. External influences like magnetic or electric fields leads to environmental errors. Probably you have wrote answer to the following question. Following are the references. Thank you.